Thank you so much. Thank you. Good morning, everyone. Thank you very, very much for having me. So, just a couple minutes on myself. My name is Elad Nafshi. I lead what's called the Next Generation Access Network at Comcast. I will walk you guys through the details of what the access network is. I've been with the company for about 15 years now, which is kind of hard to believe, but it's just such a great company to work for and work with, and a great opportunity to transform this industry. So I will come clean and say that I just got back on a red eye from Frankfurt, which, if anyone has ever taken a flight from there, you would ask yourself, how could Frankfurt be an airport in Germany? It's an interesting place, and I'm jet lagged like I can't even describe. And so, Hussam, I'm going to ask you that if you see me fall asleep, just kick me, okay? We are. Here we go. So, over the last week, I was actually riding motorcycle. Nope, that's too much. Hold on. Here we go. For the last week, I was actually riding motorcycles through the Alps with friends of mine. And those are, live photos. And so, as recent as yesterday, I was still very happy on a motorcycle in Slovenia. And we rode through Slovenia and Switzerland and Italy and Austria, and it was wonderful. But I made my way all the way back here because I have such exciting news to share with you guys. But first, I will take you through some obligatory engineering slides, okay? I can't just jump into the good news. But what I'm also going to do is I'm going to try and keep some time for questions at the end, and we'll try and keep this as interactive as we can. Okay? Now that road in the middle picture, that's an actual road. This is in northern Italy, and it actually reminds me of the long winding road that got us here to virtualization of the cable network. And let me tell you, it's been winding. Okay? So with that, let's talk a little bit about the Comcast Access Network. And so, as of the end of last year, we had about 57 million homes passed in the US, okay? That means that our network passes roughly half of the households across the United States, okay? And in terms of the size and the scope of this network, it's massive. We have about over 180,000 fiber miles and about 500,000 miles of coax cable deployed across the communities that we serve. And just to put it in perspective, anyone knows how far the moon is away from Earth? Anyone? There's so many geeks here, come on. It's about 239,000 miles, right? So, you put this network end to end, and then, you could reach to the moon 3 times. That's how big our access network is, okay? And, when you look at the topology of, how we're serving our customers, we start from the left with an appliance today called the CMTS, or the Cable Modem Termination System. And what that is, it's a box that basically aggregates the devices that are installed downstream, and then aggregates the traffic and sends it up to the internet, and from the internet down to those devices. It also serves as a point of demarcation where the traffic transitions from digital format to analog, and then we rely on analog optics to send the traffic down to what we call a node. A node is an optical aggregation point. Like I said, it's analog today. And from here, the network crosses over from fiber to coax, and those coax strands feed our 57, 58 million homes. Okay? That's kind of our standard architecture. Now, the limitations that we have are, because we rely on analog optics, there's a distance limit of how far away that CMTS could be away from the customers, number one. Number two, as we continue to grow, and I'll talk about this in the next slide, at the end of the day, because it's an appliance, it aggregates a fixed number of wires. And so, what we have to do is we have to continuously grow and maintain this network as we continue to add subscribers. From a frequency standpoint, a typical cable plant has about 750 megahertz of spectrum available. Some of our markets are at 860, the typical traditional cable architecture. And then from an in-home distribution standpoint, we have a DOCSIS base or a standard base high-speed data device that feeds the devices in-home with leading edge Wi-Fi services and what we call our DOCSIS 3.1 or latest and greatest data delivery over coaxial network. Okay? My job is to make sure that that continues to grow and scale and let the business continue to grow and scale. That's what my team does. Make sense? So let's talk about what it means. Okay? So I don't know if you've been watching Comcast. How many of the folks here are Comcast customers? Show of hands. Not enough. We need more. We need more because I'll tell you what happens, right? So as you guys continue to jump on and use the internet, okay, there's an entire section of my team that does nothing but watch the traffic on the edge to make sure that every time that you go online, there's enough capacity for you guys to enjoy the speeds that you're paying us for, okay? And so what happens, how do we do that magic? Well, there's a couple ways. First of all, we could aggregate more capacity, more frequencies to high-speed data. And that's kind of what you're seeing at the bottom there, where over time, more and more of our channel distribution is actually allocated and dedicated for high-speed data distribution, okay? But that can only go so far, okay? Because one, without going into the generations of devices, there's only so many channels that a modem can aggregate together. And then at the same time, freeing up capacity is not easy. It's consumed by something else right now, okay? And that's a finite resource. And so what happens over time is that we actually go and a node goes red. In other words, there's not enough capacity. And we have to go through what we call a node split, okay? And when we go through a node split, we take that node and we physically split it into two, okay? So we have guys go out on bucket trucks and pull additional fiber and physically split the plant into two. And when we do that, we effectively double the amount of capacity that is available to every customer, right? Because if before we were serving, just as an example, 100 customers, now that same amount of capacity is available to 50 customers. And we do that many, many times every year, again, in order to make sure that we are delivering on our speed promises to our customers. Now, because we rely, as I mentioned earlier, on an appliance that can aggregate so many wires before you need another one, what you start to see in the facilities is that those things start to pile up, okay? The more nodes you have out there, the more wires you're gonna need to aggregate. The more wires you need to aggregate, the more boxes you're gonna need. And when those boxes start to pile up, and these are power-hungry, big machines, lots of fans, et cetera, Broadcom proprietary hardware that's currently, we deploy Aris and Cisco. There's several other companies that do these boxes. What you have is a real strain on our entire distribution channel of how do we continue to enable this growth without building shopping malls for facilities, okay? And so what do? Well, we have a challenge of, look, I'm not gonna tell you that every one of our facilities look like that, okay? But that is an actual hub site in Seattle, okay? How many more CMTSs do you think we could fit into that one? Not a lot, right? And so what do? Well, we rely on the brilliant engineers that we have, and we have Rob Howell, who's been very active in ONF over the last several years, who's really been leading a lot of our development here, and a whole bunch of really smart people, across the industry and across Comcast that said, okay, well, let's take a step back for a second and let's look at the evolution of this platform. Okay, and so if traditionally we were reliant on an appliance proprietary bookended solution, right, that was relying on analog optics, let's look at all this progress that has been made with cloud computing in general and say, hey, is there a better, different way of doing things? And the architecture we came up with, which, I'm sure the telco folks here, would recognize as, very similar to traditional cord architecture, is really built around the following premise, okay? We want to drive virtualization and we want to drive open software as hard as we can, okay? Why? Because we're now driving economies that are fundamentally different than the proprietary closed bookended solutions that we've relied up until now. And so as we start from the internet and go downstream, the platform itself, the CMTS, is just software running on compute. It's running on proprietary platforms right now, but there's really no reason why it has to, right? And so what we've done is we partnered up and we built a virtualized version of the CMTS that's running on x86 platform, which, oh, by the way, every 18 months will become twice as powerful by just running Moore's Law instead of different proprietary innovation centers. And then we could run it on VMs and try and cut corners, but why would we? Why don't we build this right and put the right HA model in place and rely on modern software implementation with containers, Kubernetes, et cetera, that really has failure molecules as small as we possibly can make them, right? And so, for example, for us, a software container is dedicated to a digital node, which we'll talk about later downstream. If one fails, we'll just spin up another one. That's what the platform is built for, okay? And then as we go further down into the switch and spine architecture, obviously we want to make sure that this is a highly redundant, highly available platform. And we had a decision to make here, okay? How do we orchestrate this? What do we build? We chose to go down the trellis route, and because I'm speaking in an ONF crowd, this is the decision we made, okay? And it was a big decision. It wasn't an easy one. What made it possible is a lot of the open community and open source work that has been done in order to really bring this kind of innovation into carrier-grade deployments, if you will. Okay, and that enabled us to choose white label switches, which obviously gets us to a substantially different price point on what this switching fabric looks like, and candidly, driving us towards an innovation cycle that is much, much, much faster than you would have otherwise done with kind of traditional switching. When you continue to go down, you'll see that with this architecture, which we call DAA, Distributed Access Architecture, we have moved the point of D to A conversion from the CMTS, which is what is encumbering this big box, into the nodes, and we turned our nodes from analog to digital, okay? And that's this RPD block over there, and what that means is that we can now rely on digital optics leading from where the CMTS is all the way down to the nodes, which means distance is no longer a big deal as it used to be, number one. Number two, I now have a 10 gig link going down to each individual node, and we'll talk about the ramifications of that later on. And then the gateways stay exactly the same. The customers should not care whether they're fed out of a vCMTS or whether they're fed out of a CMTS or whether they're fed out of a PON network. It doesn't matter. They're paying us for the service. We need to deliver the service. That's my team's job. And so if you translate that into the architecture that I shared with you guys early on, you'll see that now, instead of being in that secondary location, those smaller, less suited for web gear, we can now take a step further upstream in the network and put those web services in what we call the primary locations. Obviously, far less number of locations, meaning we can harden them, we can put the right temperature control, and we can make sure that the devices are much more highly reliable than they would otherwise be. And then the local facilities, that little shed that I shared with you, really become analog aggregation points, right? There's fiber going down from the major facilities down there. There's a new device that we call the DAS, or the Distributed Access Architecture Switch, which is just a very simple switch, cost-effective, that is enabling us to aggregate those digital nodes, those 10 gig links that go down to the nodes. And all of that magic is controlled by the Trellis orchestration. Okay? Now, as we go down and as we push the digital architecture further down, one of the key benefits that we have is that a digital connection is binary. It's 0 or 1, okay? Which makes it a lot more robust than an analog connection, which has 50 shades of gray connectivity to it, okay? And so not only is the connection that much more robust, okay? It actually creates a much, much better user experience to our customers because the signal level tolerances are much better, and we're now able to serve the most important thing in the world, which is high-speed data connectivity in a much more robust and reliable way. And by the way, with this architecture, in a much more cost-effective way, okay? And the story I always share is I have a 12-year-old, and last year, school year, there was some parents-teachers conference, and he stayed home, okay? And so, at a leisure 11 a.m., he wakes up, and there was actually electrical work done on my street. They're doing a lot of tree trimming, and the power was down to the house, okay? And I get like 8 calls from him in a span of 3 minutes, right? And so I walk out of the meeting that I was at because, oh my God, what's happening? And I call him and say, what's going on? And he tells me the internet is down, okay? And it's like, okay, is there power in house? Because I know they disconnected. It was like, oh, I don't know, but the internet is down, okay? And that's how important and that's how much our customers rely on us to deliver the services. Now, if you look at what it means from a plant standpoint, notice that with this digital architecture and digital infrastructure, we're also enabling us to expand the amount of bandwidth that's available to us, right? And so if a traditional cable plant analog is 750 or 860 megahertz, the digital plant extends all the way up to 1.2 gig, giving us a lot more capacity to continue to grow our services, our data services, and our speeds well into the future, okay? So let's talk about what else we get out of this. And this is an actual photo of one of our data centers. This one is in Atlanta. And on the left-hand side, you see a traditional legacy CMTS. You see all those cable, those analog connectors and all the analog combiners and all that gear at about 10 racks worth, feeding about 192 service groups or 192 nodes, okay? And then on the right-hand side, you see the VCMTS serving the same number of nodes. Anyone wants to know why we needed to virtualize? Any other questions? I think it's pretty self-explanatory. And the funny thing is that it's on the same floor, right? So this is kind of like the left-hand side is on the left side of the floor, and the right-hand side is on the right-hand side. When you walk in and you see the number of racks, which I won't go into the numbers, on the right-hand side versus the rows and rows of gear on the left-hand side, it becomes pretty self-explanatory. And pretty exciting. It really is. It's pretty exciting. So, let's talk about what else we're getting out of that. And so I mentioned earlier that the CCAP or the legacy CMTSs are really, fixed-wired type of appliances, right? There's so many nodes, you get so many nodes connected into that device. But capacity in the network is not uniform, okay? Capacity in the network fluctuates. It fluctuates by the type of customers that are on it. It fluctuates by the time of day. It fluctuates by the access delivery. I keep talking about, coax, but it doesn't have to be coax, okay? And so, if, the top node is my house and my kid is online playing Fortnite, right? I want to make sure that he's got the right capacity going there, okay? And then it's now the afternoon, and kids who did go to school come in at 3 p.m. And that, by the way, is one of the peak hours, right? Kids come back from school, first thing they do, they turn on the TV, they go online, okay? Or, maybe there's another node where, there's a business services there, commercial services, and they consume traffic throughout the day and less so at night, right? The residential peak hours are 7 to 11 p.m. The commercial peak hours are different, right? And so wouldn't it be great if the core would be able to flex and make sure that we're allocating capacity based on the actual demand. And that's what virtualization really enables you to do. Okay? You no longer rely on fixed wires. You're now allocating compute to where compute is needed. And that's what makes this so transformational. And that is what brings me to this. So it delights me to no end, and really why I've taken motorcycle, trains, and airplanes to come here today and be in front of you and share with you guys very exciting news that Trellis is live and is feeding live customers at Comcast. I know that there's been tremendous amount of work from a lot of folks here in this room, and some of the folks who are outside, and we're going to have a little bit of an award ceremony when I'm done talking to recognize some of those key individuals. But I'll tell you, this has been an awful lot of hard work that went into making this happen. This is not a plug and play by any stretch. This is a very complex software-defined network implementation that has never been done before, and we were honored to lead the charge on. And so it's a very exciting milestone. It's a very transformational milestone. And put the technology aside, it's, I think, very exciting technology for our customers because it will allow us to continue to serve the absolute best broadband service, bar none, in my opinion. No AT&T people here, right? So there you go. So let's talk about a little bit what else comes with, okay? So what I'm showing you here are actually 2 live screenshots of our real-time telemetry, okay? And those are things that when you're in a web world, you kind of take for granted. But in a traditional CMTS world, that's a device that still relies on SNMP trapping and CLI commands, okay? And so if I want to get visibility, I can get visibility, but it will be in increments, okay? Versus a highly automated cloud-based push platform that gives me visibility down to the second on what goes on my network, okay? And so the top one is kind of an aggregated view of all the key points, the RPDs, the cable modems, the traffic across the service nodes. And then the bottom one is actually a laser-focused view on one node that was experiencing power outages, okay? And you'll see those red nodes are basically, disruption in data flows. And it's so hard to chase down these, intermittent issues because, we know there's something wrong, but we can't see where it is because, it really depends on where the data capture happens versus it's right there, it's real time, and send someone to look at the power supply because there's something wrong here, okay? So that's the transformational operational model that we're now able to put together with this platform. Now, in addition to that, I talked earlier about the nodes, okay? Well, think about this. When these are digital nodes, they send out real-time telemetry, and they're really compute units sitting out there. And they're connected to a 10 gig link, they're real-time communication. Instead of relying on calls and processes and tickets, when those guys go out there to service or activate those nodes, they all have cell phones, right? Well, why don't we arm them with the tools in order to actually activate this, okay? So what we've done is we built an app for our line techs that as they pull the 70 pounds worth of aluminum, which is the node, and they get into that bucket truck and they climb up to the pole and they hang the node, they pull out their cell phone, they scan the barcode of that node, and in real time that node activates, and within the time that they all finishing up the work and all the connectors, they already know how many modems are online, how many modems were online before, is there anything that we need to go out and fix at home, and is there any plant-related issues that they need to resolve before they climb off the pole? And that is the advantage of a real-time virtualized platform, okay? Now, for folks who've, and I'll go back to this, for folks who've been around these things know that, there are billing system companies that have built empires on building, systems like that, right, literally. This is one of those where you go to your CIO and you ask for something and he will say, that's great, it'll be ready in 3 years and it'll cost us $180 million, right? Let me tell you a secret. We had 2 Drexel interns pull these dashboards together in 2 weeks as a side project. Why? Because it's a website. It could be whatever you want it to be. And so they sit right next to my ops team, and the ops team say, I want this view and that view, and okay, fine, here you go. It is almost liberating, right, to run a platform like this without relying on CLI commands and mainframes, et cetera. And the same for this. This is just an iOS app that some of the Infosys folks who are here helped us build. And it is truly transformational for our line techs. And so it's not just technology for the sake of technology. What enables that makes it kind of our transformational platform. I mentioned, our broadband leadership and how important that is, and this is kind of a view on how we continue to be the broadband leader out there from a speed standpoint. Most recently, we launched our 1 gig services about a couple years ago, relying on what's called DOCSIS 3.1, which is the latest data delivery over coax spec that enables us to serve customers with up to 1 gig service. Earlier this year, we announced our 10 gig initiative, which is next evolution of broadband services with speeds of up to 10 gig. And that's really how we continue to evolve our high-speed data service. The DAA platform is really a precursor and an enabler for us to be able to continue to grow our internet speeds into the future and to continue to be the broadband leader in terms of high-speed data delivery. Okay? So with that, and with about 3 minutes left, I'll pause and I'll open it up for any questions.
Yeah, so please, this is, I'm sure a lot of you have questions, so go for it.
Go ahead, Sam. You didn't have to kick me. I'm actually I'm proud of myself.
Yeah.
Go ahead.
Questions?
Yes, I have a question.
Oh, sure.
Comcast started this activity way behind other companies. Comcast started this virtualization activity way behind others that started years before. How did you guys manage to get actually a system working in such a short time?
So without making fun of AT&T, although it's really hard for me right now, I'm just joking. We have the best team, we really do. We have an extraordinarily talented team that was able to pull together and execute this. And candidly, there's an awful lot of work right here in this community that enabled us to get there. I think that we made some changes in the ONF structure that really made a lot of the activity be more operator pushed. I think it certainly helped make sure that we are driving the right items from our standpoint, and then we just relentlessly execute, which Comcast is very well known for. So a lot of hard work with Sam, a lot of hard work, trust me. Yes, go ahead.
Just wanted to say that logo's great, but why the choice of the logo?
So I came up with the logo, okay? And it is not a shark, it's a dolphin. It's in fact a mean dolphin, okay? And it's a dolphin, it's gonna be a little corny, but wait for it because we're flipping awesome. And that's what's behind this logo. I'm sorry, I'm not a marketer.
So Elad, I know it is on everybody's mind. I mean, you said Trellis is live and that's all great. I'm sure people are wanting to know, can you say anything about the scale?
So
I know you, I know maybe I'm not supposed to ask this question.
I cannot, I'm sorry. This is something that we don't disclose, but I will tell you that it is not a technical trial or proof of concept trial or anything like that, which I know some of the folks here a couple days ago talked about. This is a real launch. So it's a real launch and it's serving live customers. Other questions? Anyone? Okay. Yes? Okay, excellent. How soon will Trellis come to your neighborhood? It's actually not that far away. And I'll leave it at that. Soon.
Okay, go ahead.
So Elad, thanks for coming and sharing all the work you've done. Impressive amount of energy and result so quickly with the community and your team. It has to beg the question, so what's next?
It's a really good question. So I would put this, probably into 3 buckets, okay? Number 1 is reliability, reliability, reliability. It has got to work, okay? We don't build technology for the sake of technology. We build technology to serve our customers better, okay? And so, I can't stand on this stage as much as I would like to and say Trellis is perfect. It's not. Okay, there's a lot of work still ahead of us in order to make sure that we're driving the hardening that the platform needs in order to continue to grow. So that's number 1. Number 2 is scale. Okay, it's one thing to deploy a couple of nodes, somewhere in Texas. It is substantially different to walk into San Jose, okay, and put a digital node on, and be able to scale, to many, many, many thousands of nodes. And that's a big challenge, and that's something that the team is laser focused on. And then the third piece is, we have done something that is very unique, which is we have not deployed a new appliance. It's not that you go from the previous model of the CMTS to the new model of CMTS. We deployed an entire ecosystem, and what we need to do is that as the ecosystem grows, it has to expand into additional capabilities for the ecosystem, not just for the individual pieces. I shared the operational dashboards. How do we continue to grow that? I shared the line tech applications. There's a whole series of other enhancements that we want to make, both on the core platform, but also on the peripheries, in order to truly enable it to be a much better ecosystem, not just a much better appliance. Okay, so that's in a nutshell, and obviously being the foundational for the 10G work is very exciting, and you're going to see, I think, a lot of great things from us as we continue to make progress on 10G. Last question?
Okay,
No?
maybe one last question, but we're...
Anyone? Okay, so now we come to the ceremonies. Excellent.
Yes.
Thank you.